This is a video of how to complete the Newton's second law lab. It's part of our Flipping the Lab series. The purpose of this lab is to derive Newton's second law. Our list of materials and equipment include a data collection system, in this case the GLX, a force sensor, a motion sensor, a cart, a track, and a triple beam balance. Please use the picture to the left and the video of this lab that you're about to watch to sketch a labeled diagram. Hardware setup. Start by pressing this button to turn on the GLX, and then what we'll do is we will connect the motion sensor by plugging it into the top of the GLX, just like that. Then we'll connect the force sensor by taking the other end and attaching it just like that. There's a certain way that it goes in, just like that. So the motion sensor and force sensor are attached. We'll take the motion sensor and attach it to one end of the track. And then we also have to attach the force sensor to the cart. So you'll need this long thumb screw. It goes through where it says cart. Okay, we plug that in, and then that goes directly on top of the cart, just like that. So we have that set up there. Okay, then what we want to do is we want to take the cart, put it on the track, just like that. To finish up our hardware setup, let's make sure we've got the motion sensor at the right setting. On the top of the motion sensor, there's two settings, one for the cart and one for a person. You want to make sure that that switch is pushed over to the cart setting. Another thing we want to make sure we do is when we've got the hook connected to the force sensor, we want to make sure it's not too tightly plugged in or screwed into the force sensor. Another thing we want to do is when there's nothing connected to the hook, as it is right now, we want to press the 0 button or the tear button on top of the force sensor. That just zeroes it out. Okay, now we're all ready to go. Alright, what we want to do now is we want to set up the software. The first thing we want to do is set up the vertical axis so that it reads force pull positive or force inverted, depending upon the type of GLX software that you have. The way we'll do this is we'll press the green check button right in the middle of your keypad. We'll press it twice, so there I'll press it once. Okay, that highlights the vertical. Then I'll press it again, and that gives me some options. Now what I'm going to do is I'm going to look for force pull positive or force inverted. So I believe if we press the down button a couple times and we select right under force where it says more and press the check button, that'll give us force inverted. So it's highlighted there already, so I'm just going to press check, and that will make the vertical axis force inverted. Then what we want to do is we want to change the horizontal axis so that it reads acceleration. The way we'll do that is we'll press the check button. Now this time we're just pressing it once, and notice again it highlights the vertical. We'll press the down arrow once, and now it highlights the horizontal. Then let's press the check button again, and that gives us some more options. Now underneath position, you'll notice that there's an option for more. I'm pressing the up arrows to get to it. Now I'm going to press the check button to select more, and I'm going to look for acceleration. There's acceleration, so I'm going to press the down arrow to select acceleration. And there we go. We're all set up. Our vertical reads force inverted and our horizontal reads acceleration. The last thing we want to do as far as software setup is concerned is to get rid of the connected lines. So I pressed F4, and that got me the graph selection. And once I get there, I'm going to scroll down to the connected lines. I'm going to press check mark so that we get rid of connected lines. And that should be the last step that we need to do as far as software setup is concerned. Now that everything's set up with the hardware and software, it's time to gather some data. But it's probably a good thing to double check a couple things. The first thing is to make sure that the motion sensor points parallel to the track so that it's recording the motion of just the carts. The second thing is to double check that we zero the force sensor. Just press the 0 with nothing touching the hook. Just press the 0 there. And then we're all ready to go. To get things started, let's press the start button on the GLX. The start button on the GLX is a little triangle. So notice in your GLX screen there that it'll be circled as soon as I press start. You'll hear the clicking of the motion sensor, and what I'll now do is I'll go back and forth holding the hook and going back and forth in front of the motion sensor. And then I'll hit the stop button. It's the same button on the GLX, and we'll look at our data. So the first thing we want to do is we want to auto scale our data because it's too hard to read. If I press F1, which auto scales, it gives me a scatter plot of my data. If I like my data, then I go ahead and I press the Tools button under F3, and I scroll down to Linear Fit, and that gives me a linear fit of my data. If I don't like the data, for example, if I have too many points that I think are erroneous, what I would then do is I would just start over by pressing the check button, going over, pressing the right arrow button so that run 1 is highlighted, press the check button, and then I go down to delete all data runs. And I start again. I press OK to delete all data runs. So now I can start this again so that I can see this graph a little better. I'm going to turn off the linear fit, and I'll start it again. I'm going to press the check button. I'm going to go back and forth. Maybe just a few times. I'll hit stop. Look at my data. Okay, now my data more or less fits along a particular line. There's a few outliers, but this is a little better. So I'm going to press the Tools button, go down to Linear Fit, and get the value of my slope. You notice the value of this slope is down there on the bottom left-hand side. After you complete the lab, sketch a graph of your original data with labels and units. Make sure you include the slope. And for your calculations and derivations, write a linear y equals mx plus b equation of your graph using the correct variables and units.